Okay, let's talk about even and odd identities. We said before that sine function is an odd function, cosine function is a even function. Also, tangent, cotangent are odd. So we have these functions that are odd functions, and we have cotangent and secant, which are even functions. Now, what does that mean? Well, basically the odd function is like if f of x is odd, then if we supply negative x or the opposite of x, so the value of the entire function changes the sign to the opposite. So if the input is opposite, the output is also opposite. Okay. Now for the even functions, if f of x is even, then when your input is negative, the output is still the same f as the output of f of x. Basically, the even function absorbs this negative sign inside of it. So on the output, it's still going to be positive. So for the odd function, you put the negative inside, you get the negative on the outside. For the even function, if you have the negative inside, it does not affect the outside at all. Now, some functions are even, some functions are odd, and some functions are neither. But in case of our trig functions, they are even or odd. So sine and cosecant are odd. And of course, if sine is odd, cosecant is 1 divided by sine, so it has to be odd as well, so because they are reciprocals. Same with tangent and cotangent. They're both odd. They're reciprocals of each other. And cosine and secant are even. Just keep that in mind. What does that mean on the graph? So we see that here the input is pi over 2. So the output is positive 1 for the function sine of x. Now, if we change the input to the negative pi over 2, the output is also negative, becomes negative, right? So opposite input, opposite output. Now for the odd function, in case with cosine, here we have the input of pi over 4, and the output is the y value here is 0.707 for the cosine x function. Now, if we change that input to the negative, the output is still 0.707. So this is how it works, the odd and even. Now, example, prove that tangent theta is an odd function. So in order to prove, so if it's an odd function, that means that tangent of negative theta is going to be negative tangent theta. So in this case, it's going to be an odd function. That's what it means by definition. All right, let's take a look. We're going to start with our left side of, we're going to prove this identity. We're going to start with the left side, which is tangent of negative theta. And we're going to rewrite tangent as sine over cosine. So we have sine of negative theta divided by cosine of negative theta. Well, because sine is an odd function, it's going to be equal to negative sine of theta. and cosine is even function, so it just absorbs the negative. So cosine of negative theta just becomes cosine theta. Now, what is that equal to? We could put the negative to the front, and sine theta over cosine theta is just a tangent theta. So we started with tangent of negative theta, and we ended with negative tangent theta, which is the right side of this identity. So we just proved this identity. So that was question A. Question B says, if cotangent theta is cotangent theta even, odd, or neither? So in order to answer the question, we have to substitute theta with a negative theta and see what happens. Are we gonna get the opposite or negative cotangent theta, or are we gonna get just cotangent theta, or we're gonna get something else? In this case, it's gonna be neither. Let's take a look. We're gonna rewrite cotangent of negative theta as tangent, cosine, cosine divided by sine. Cosine negative theta is just cosine theta because cosine is even, and sine is negative sine theta because sine is odd. So again, we have negative cosine theta over sine theta, and that gives us a negative cotangent theta. So we could see that cotangent function is an odd function, just like we mentioned before, and we just proved it. Later when we're simplifying other expressions or proving the identities, we're going to use the fact that these functions are even or odd in order to simplify expressions. Now, what are other identities that we're going to use? Well, we're going to use our reciprocal identities. Sine is 1 over cosecant, and cosecant is 1 over sine. Cosine is 1 over secant, secant is 1 over cosine, and tangent is 1 over cotangent, and cotangent is 1 over tangent. Also, keep in mind your quotient identities, we already used them. Tangent theta is sine over cosine, cotangent theta is cosine over sine. We're going to use all of these identities. Now, sometimes if you're taking calculus or some other higher level math classes, you will get answers that look different, but they still represent the same thing. Like we mentioned before, trig functions could look a little bit tricky. You can get the same graph by using sine function or cosine function, just shifted a little this way or that way, and you're going to get the same graph. So the way to verify that two equations actually represent the same values or the same graph is to graph both of those expressions. So let's do it here. It says graph both sides of the identity cotangent theta and tangent theta to prove basically that they're the same thing, to prove the identity by graphing. And I'm going to do that using Desmos calculator. which you're already familiar with. So I'm gonna basically write y equals cotangent theta. In this case, I'm gonna use x cotangent x because I did not rename my axes. And the next one is y equals 1 divided by tangent x. There you go. So do you see how one graph coincides with the other graph? So my y equals 1 over tangent x is in blue, and y equals cotangent x is in red. And when I click on one, it activates, and you can see how they're basically the same graph. And that proves that it's an identity. Cotangent of x is the same as 1 over tangent x. So you could also prove the two expressions are identical by graphing them and looking at their graphs.